In this video, we will try to understand the concept of principle of reversibility of the path of light. What is the meaning of this? The path of a light ray is reversible. To understand this, let us consider two different scenarios which will prove that a path of a light ray is reversible. So, here in the first scenario, you can see that when a ray of light is passing from medium 1 to medium 2. So what do you understand by medium 1 and medium 2? Here the medium can be anything. Here the light ray can pass from glass to water or water to glass or air to glass or glass to air. So here the light ray is passing from medium 1 to medium 2. So here you can see there is a plane surface S dash, and the light ray, incident ray, that is AO, is getting incident at an angle at medium 1 surface. Now once the light ray is entering into the medium 2, you can see the light ray has bended towards the normal. So this bending of ray is known as refracted ray. So here the refractive index of a medium 2 with respect to medium 1 is written as mu12, that is equals to mu2 by mu1. So here mu2 is nothing but sine angle of incidence by sine of angle of refraction, that is equals to speed of light in medium 1 with respect to speed of light in medium 2. So now let us understand the scenario 2, when a ray of light is passing from medium 2 to medium 1. So here again the plane surface is SS dash, and now the light ray is going to enter from medium 2 to medium 1. So here BO will be considered as the incident ray. Okay, BO will be considered as the incident ray at an angle I, and it will enter into the another medium, that is medium 1. So now here OA will be considered as the refracted ray at an angle of refraction. So here previously OB was considered as the refracted ray, but so now due to principle of reversibility of path of light, BO is considered as the incident ray and OA is considered as the refracted ray. So now here in medium 2, this ray is considered as incident, and in medium 1, OA is considered as the refracted ray. Now, the refractive index of medium 1 with respect to medium 2 is nothing but mu21 is equals to mu1 by mu2 equal to sin r by sin I equal to v2 by v1. So now from both the equations 1 and 2, when we equate, what happened? Obviously these angles will get cancelled and you'll remain with the answer 1 to the right side. So you will get mu12 into mu21 is equals to 1. So now from this one we'll try to get two different equations. So now this was the one which we got, that is refractive index of medium 2 with respect to medium 1 into refractive index of medium 1 with respect to medium 2 is equals to 1. Now if I want to derive an equation only for refractive index of medium 1 with respect to medium 2, then it will be equal to 1 by refractive index of medium 2 with respect to medium 1. Or suppose I want to derive an equation for only this one, refractive index of medium 2 with respect to medium 1, then I'll get this equation, that is 1 by refractive index of medium 1 with respect to medium 2. Now when you know both the equations, it will be easy for you to solve the examples. So let me explain you one sample example. Here, if refractive index of glass with respect to air is nothing but 3 by 2. Okay. The statement here, the refractive index of glass with respect to A is written as mu Ag is equals to 3 by 2. Now, I want you to understand how we will write if refractive index of air with respect to glasses. So then obviously it will become reciprocal and it will become 2 by 3. by using the above equation. Is it simple, right? So it will just become reciprocal. That's it. 3 by 2 will be converted to 2 by 3. Now I want you to try this example. If refractive index of glass with respect to water is 9 by 8, then what will be the refractive index of water with respect to glass? Find it out. It's very easy. So now let's understand the concept of refraction of light through a glass block. So here PQRS is considered as a glass block and air is considered as a rarer medium and glass block is considered as a denser medium. So here the incident ray, that is AO, when it is entering from rarer medium to denser medium, that is glass block, you can see that the light ray is getting bended towards the normal, that is NOM. Okay, so this bended ray inside the denser medium is called refracted ray. Now again, the light ray is, when it is coming outside from the other side of the glass block, you can see that the speed of light get increased and the light ray is moving away from the normal, that is N1B M1. So now the ray which is coming outside the glass block from the other side is known as the emergent ray. It is given by the symbol E. So here the incident ray, when we are extending with the help of the dotted lines inside the block and outside the block. So the extended dotted line is known as direction of incident ray. And you can see there is a distance, perpendicular distance forming between the direction of incident ray and the emergent ray. So that perpendicular distance is given by the segment XY. And this perpendicular distance is known as lateral displacement, which we will be learning further. So now let us understand the terms related to the refraction of light through glass block. So here AO is incident ray, OB is refracted ray, and BC is nothing but the emergent ray. And here OD is nothing but the direction of incident ray. Now here angle AON is equals to angle of incidence and angle BOM is angle of refraction. Angle CBM1 is nothing but angle of emergence, and here PQ and RS are the two surfaces where refraction occurs. Okay, and we know that angle of incidence is equals to angle of emergent ray due to principle of reversibility of path of light. So now let's understand lateral displacement. Now let us understand lateral displacement. As I said you earlier, the perpendicular distance between the direction of incident ray and the emergent ray is nothing but lateral displacement, that is XY. So here the incident ray AO, okay, the incident ray AO and the emergent ray BC, they both are parallel to each other, but both are not along the same line. They are just parallel to each other. So the perpendicular distance XY between the path of emergent ray BC and the direction of incident ray OD is called the lateral displacement. Lateral displacement depends upon three following factors, that is thickness of the medium, angle of incidence and refractive index. If thickness is more, lateral displacement will be more. If angle of incidence is more, lateral displacement will be more. And if refractive index of the medium is more, obviously lateral displacement will be also more. These are the three factors on which the lateral displacement depends.